Hi everyone, welcome. Today I'm going to show you how to differentiate using the power rule. If you've never differentiated before, don't worry. So here's the power rule. It looks a bit complicated to begin with, but there's a really simple way to remember it. So if we have something like x cubed, all we're going to do is we're going to bring the 3 down to the front, so 3x, and we're going to reduce this power by 1, so 3x squared. It's as easy as that. The same goes for x to the power of 4. Bring the 4 down to the front and reduce this power by 1. So the answer is 4x cubed. So before I write the rest of this, have a think of what you think the derivative of x to the power of 5 will be. So we bring the 5 down to the front, and then we reduce the power by 1. So what do we do when we have x on its own, or x to the power of 1, which is also x? Well, in this case, we're going to bring the power down here. So we get 1x, and we're going to reduce the 1 to a 0. So we have 1 times x to the power of 0. And anything to the power of 0 is 1. So this just becomes 1 times 1. So x to the power of 1 becomes 1. You might be asking now, what do we do with constants? With numbers like 5, 7, 13. What do we do with these numbers when we differentiate them? Well, there's a different rule for constants, and it's a constant rule. So the derivative of any constant is equal to 0. So the derivative of 5 is 0. The derivative of 7 is 0. And derivative of 13 is 0. And any constant number, the derivative is 0. So what do we do when we have a term with a multiple already in front? Well, we still bring the power down, but this time we multiply it by the term that's already there. And then just reduce this power by 1. So what we do is do 4 times 3 here, which is 12. And then reduce this power by 1 here to get 3. So the answer is 12x cubed. Let's try another one. 2x to the power of 7. So we do 7, we bring that down and multiply it by this constant. That means it's 14x. And we reduce this number here, 7, to a 6. Next, we're going to look at ways where all of these are together in one expression. So if we get this expression, for example, mixed, we have to differentiate the terms individually. So usually what I like to do is draw a little box around each symbol as it starts like this. So I can see how many terms there are. So it's 4 terms here. And then we just differentiate each term individually. So what we'd start with here is we bring this 4 down in this term, and we get 12x cubed plus, bring the 7 down here, so that's 14x reduced by 1 to the power of 6 plus, now this is a constant, so constant rule says that if you differentiate a constant, it just becomes 0. And here we have the power as 1. 2x to the power of 1, so we just stick with the 2 and we reduce the power of this to 0, which means that's 1, so it's just 2 there. So the final answer is 12x cubed plus 14x to the 6 plus 2. And you can factorize this if you want to as well. You could take the 2 out and you could get it at 2, 6x cubed plus 7x to the 6 plus 1. So to recap, we have the constant rule and the power rule. And these two rules are really handy and easy to learn in getting to know differentiation. The best way to get better at differentiating is practice. So I provided a workbook in the description below if you want to have a go at some more difficult questions to do differentiation. Thanks for watching. Please consider liking and subscribing if you like the video, and see you next time.